Hi, this is Mr. Snyder with Truman Middle School, and today we are going to learn to find the volume of pyramids and cones. So our vocabulary today, of course, will include the words pyramid and cone, so let's go ahead and define exactly what those are. There are several different types of pyramids, and a pyramid is always defined by its base, but here are two examples, the more common rectangular pyramid and a triangular pyramid, as well as a cone. So a pyramid is just simply a three-dimensional figure whose base is a polygon and all of the other faces are triangles. Remember that a prism had faces that were rectangles. So that's the difference between a prism and a pyramid is the shape of the faces. And just like the prisms, these are always named by their bases. So the examples we have here are, of course, the rectangular pyramid, since it has a rectangular base, and the triangular pyramid, since it has a triangular base. A cone always has a circular base, and the height of a pyramid or cone is measured from the highest point to the base along a perpendicular line, indicated by the red dashed line, and that is the height. So let's go ahead and look at the formulas for both of these. Notice that they look pretty similar to the formula for prisms and cylinders. The only difference now is the fraction 1/3. So the formula for the pyramid is volume equals 1/3 big B times the height. And remember that big B is the area of the base. So you always have to calculate big B first and then plug it into the 1/3 big B times H formula. For the cone, same thing. Volume equals 1/3 big B times height. And in this case, since you have a circular base, big B, as they show there, is going to be pi r squared because that is the area of a circle, which happens to be the base of a cone. So those are our formulas. In the example for the pyramid, they show you a rectangular pyramid. So the first thing we needed to do was find big B. So using the length times width formula for rectangles, we find that big B is 9 units squared. Plugging that into the 1/3 big B times H formula, you get 1/3 big B, which we found was 9, and the height in this case would be 4. So multiplying that all together, we find out that the volume of that rectangular pyramid is 12 units cubed. Similarly for the cone, after calculating big B and getting 4 pi units squared, we simply plug in 4 pi for big B and multiply that times 1/3 and also 3, which is the height. So multiplying that all together, you would end up with 4 pi, which is approximately equal to 12.6 units cubed. So those are a couple examples to follow along with. So let's look at some others. Again, when we're doing these, the first thing we need to identify is the base. And the base is a triangle, so big B in this case will be the area of a triangle formula, which is 1/2 base times height. So looking at the base and the height in this shape, the base would be 4, the height would be 7. So simply plugging those in for 1/2 base times height, we would get 1/2 4 times 7, which would come out to 14 centimeters squared. And now that we have big B, we can use our volume formula. So now I would plug in 14 for big B, and then notice that the height is 6. So writing that all in, I would get 1/3 times 14 times 6. And multiplying that out, I would end up with volume of 28 centimeters cubed. And remember, your units are always going to be cubic units anytime you're finding volume. So let's look at another example. A cone. So what we know about a cone is it does have a circular base. So in this case, big B would be the area of a circle, which is pi r squared. So big B equals pi times my radius, which is 3 in this case, squared. And 3 squared, of course, is 9. And we have 9 times pi inches squared. So that would be your big B. Of course, you could go ahead and multiply out 9 times pi at this stage, but it really doesn't matter because we're going to be plugging that into our volume formula, which is volume equals 1/3 big B times H. So plug it all in. 1/3, of course, is 1/3. Big B, we found out to be 9 pi. and the height of this cone is 10 inches. So plug it all in, let's multiply it out, and we'll approximate pi as 3.14. So plugging that in and working it out, we get 94.2 inches cubed. One more example, if we wanted to find the volume of this shape, again, the first thing we need to do is look at the base. It's a triangle, so big B in this case would be the area of a triangle formula, which is 1/2 base times height. And we have a base of 5 and a height of 7 on the base. I'm looking at the 7 that's touching the ground, not the one that's going up vertically. So plugging that in, 1/2 base times height would be 1/2 5 times 7, which comes out to 17.5 inches squared. And now using my volume formula, 1/3 big B times H, I simply plug in those numbers. 1/3 for big B, I found that to be 17.5. And the height, the vertical height of the three-dimensional shape is 7 inches. So after we multiply that out, we get 40.8 inches cubed. One more example of a cylinder, and then we'll let you start the homework. So cylinder has the circle as a base, so that means my big B is going to be pi r squared. And again, my r is 3, so I square that. I get 9 times pi, or multiplying that out, I get a number around 27 or 28. But it doesn't matter. We're going to plug in 9 pi into the volume formula, which of course, again, is volume equals 1/3 big B times H. So plugging in what we know, we have 1/3 times 9 pi times the height, which in this case is 7, and multiplying that all out, we would get 21 pi, which is approximately equal to 65.9 meters cubed. So as you can see, the formula is consistent. It's always volume equals 1/3 big B times H. So again, just like with prisms and cylinders, you always need to calculate big B first. So find the area of the base, plug it into the volume formula, and then it's just really a matter of multiplying it out. So that's it. Good luck with your homework. Please email Mr. Chrisman or myself with any questions. We'll be happy to help.